Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. SN2 reactivity depends on the degree of substitution at the carbon bearing the leaving group. Under SN2 conditions, the reaction proceeds faster at less hindered, lower substitution, carbon centers, and Br is the nucleophile provided by LiBr in DMSO, a polar aprotic solvent that enhances nucleophilicity of Br. Moving on to the next step. Identify the two electrophilic sites in the starting material. Site 1, the tertiary carbon of the cyclopentane ring bearing Cl, tertiary alkyl chloride, C1 of ring. Site 2, the terminal carbon of the CH to CH to Cl side chain bearing Cl, primary alkyl chloride. Moving on to the next step. SN2 reactions strongly favor primary over secondary over tertiary carbons because steric hindrance disfavors attack at hindered centers. The tertiary CCl on the ring is essentially inert to SN2 due to extreme steric crowding, tertiary plus part of a ring. The primary CCl at the end of the CH to CH to Cl chain is a typical primary alkyl chloride, highly reactive toward SN2. And for the final step, Br from LiBr attacks the primary carbon of the CH to CH to Cl group via SN2, displacing Cl. The tertiary CCl on the ring remains unreacted. This gives a product where the ring still bears Cl at C1 and the side chain is now CH to CH to Br, A, Br on ring, Cl on chain end wrong, tertiary SN2 does not occur preferentially. B, Cl on ring, Br on chain end correct, primary SN2 only. C, Br on ring and Br on chain wrong, both substitutions would require tertiary SN2. D, Cl on ring, vinyl group wrong, this would be elimination, not SN2 under these conditions and an unlikely pathway. Therefore, the correct answer is B. Therefore, the correct answer is option B.